So now next we have values of trigonometric functions for some standard angles. So it's a table for trigonometric functions values, which I'm sure you must have done in 10th standard. One more time I'm doing for you. Actually you need to remember all these values. As we move further you will realize. So I'll list here functions. So first let's write sine. Then next let me write cosine, then tan, then cot. Next let me write cosec, and then sec. These are the 6 standard trigonometric functions, you know. So these are the functions. And now on the other side we have angles here. These are the standard functions which we know. Now we have angle values. So first I'll take 0. Then let me write 30 degree here. Let me write 45 degree here. 60 degree here. And one more 90 degree. So here 0 degree, 30 degree, 45 degree, then 60 degree, then 90 degree. 0 degree same as 0 radian. 30 degree you know pi by 6 radian. This is pi by 4 radian. This is pi by 3 radian, and this is pi by 2 radian. If you want you can write 180 degree also, which is pi radian. 180 degree which is pi radian. So we have these values here. Okay, now even you also know from 10th standard how to prepare this, but here I'll write here directly. Sine 0 you know 0, pi by 6 1 by 2, pi by 4 1 by root 2, you know this is root 3 by 2, this is just 1. Sine pi you know 0. Now sine 0 0, so this is 1. You know that this is root 3 by 2. You know that this is root 3 by 2. This is 1 by root 2. 1 by 2. You know cos 90 is 0 here. And cos pi, you know it is minus 1. Right? Just have a look at the unit circle, you will realize. Right? This value you can just find from the unit circle. This is minus 1. Now tan, it's just the ratio of these two, sine upon cos. So this is 0, 0 by 0. You know this is 1 by root 3. This by this. Tan pi by 4 you know 1. This is just root 3. 1 upon 0, you know this is not defined. 1 upon 0. Tan 90, it's not in the domain in fact. So I'll write not defined. Or you can just put the dash. Not defined, or you can put the dash. And 0 by minus 1, you know that it is 0. Cot is just the reciprocal of this. So you can write here, or you can write cos upon sine. So this is not defined. This is again, cot is again reciprocal of tan. So this is root 3. This is just 1. Here 1 by root 3. Reciprocal of not defined is 0 because cot is cos upon sine. So this is 0. Cot is cos upon sine, which is again not defined. Minus 1 by 0. Not defined. This is not defined. You know that this is minus 1. This is minus 1 upon 0. So not defined. Okay, cosec is just reciprocal of sine function. So here 0, reciprocal, not defined. This is not defined. Reciprocal of this 2. So cosec 30 degree is 2. This is 1 by root 2. So this is root 2. This is 1 by root 2, you know. What about this? Here root 2. What about this? That's a reciprocal of this, which is 2 by root 3. reciprocal of this, which is 1, and reciprocal of 0 here, not defined, remember, not defined. Now at this place, what about next function, sec? It's a reciprocal of this, so 1, this is 2 by root 3, why? Reciprocal of this, cosec 45 degree, reciprocal of this, which is root 2, then sec 60 degree, that is 2, reciprocal of 0, not defined here, not defined. And finally sec 0, that's a reciprocal of sec pi, that's a reciprocal of this, which is again -1. Now here no need to memorize all these values, just you need to remember values of sine and cosine. Remember, these two are important. Just you need to remember values of sine and cosine. The other values you can write from there only, right? This we wrote without proofs, especially 0 and pi you can write from the unit circle. But these values we wrote directly. Sine 0, 0, sine pi by 6, 1 by 2, sine pi by 4, 1 by root 2, sine pi by 3, that is 60 degree, which is root 3 by 2, sine 91, sine pi 0. What about cos 0, which is 1, cos pi by 6, root 3 by 2, then cos pi by 4, yeah, 45 degree, 1 by 2, then here, sorry, 1 by root 2, here 60 degree, 1 by 2, cos 90 or cos pi by 2 is 0. Tan is just the ratio of these two. So this you can just imagine, you can write it. First 3 rows are important for us, remember. This we especially need to remember. The other values you can just write from sine, cos and tan. Now if I again just come back to the unit circle over here, right, let's come back to unit circle. You know that the unit circle is a circle with center at 0, 0 and the radius here, this is 0, 0 and radius is 1 unit. So this is point A where you have coordinates 1, 0, here coordinates -1, 0, here coordinates 0, 1, you know here coordinates 0, -1. What is arc length here? X equals to 0. What is arc length here? Pi by 2. You know this arc length is pi by 2. So this is called pi by 2 radian angle. What is arc length here? Pi. What is arc length here? 3 pi by 2. If I complete one rotation, arc length become 2 pi. If I continue in this anti-clockwise direction, 2 pi plus pi by 2. So it is 5 pi by 2. During second round, what about this? 3 pi. What about this? Here it would be 7 pi by 2 and then this 4 pi. You are aware with this. If I move in clockwise direction from this to this, here 0, now this become minus pi by 2. This become minus pi. This become minus 3 pi by 2. This become minus 2 pi and so on. So here arc length is 0, here arc length is 90 degree, pi by 2 is 90 degree, right? So where is 45 degree? Is somewhere here. This is pi by 4, this arc length. So here you have point pi by 4. If I call this P, then this arc length is pi by 4. Because this arc length is pi by 2, so half has to be pi by 4. Now you know that the first coordinate is cos pi by 4 and second coordinate is here sine pi by 4. You know cos x and sine x. Cos x and sine x, here x is pi by 4. And here it can be proved that this would be 1 by root 2 and this would be 1 by root 2. This can be proved that this is 1 by root 2 and this is also 1 by root 2. And that's why here I wrote directly that is sine pi by 4 is 1 by root 2 and cos pi by 4 is 1 by root 2. Pi by 4 is somewhere here, 1. Second thing, this total arc length is 90 in terms of degree or pi by 2. Now 30 degree is somewhere here if you divide in 3 equal parts, right? Here you have 30, 60 and 90. This is total pi by 2, you know it is same as 90 degree. So 30 degree is somewhere here. So if I call this as point Q for example, then Q of pi by 6. Pi by 6 is 30 degree. See here, pi by 6 is 30 degree. So this point is, if I write here, let me write here, that's a Q of pi by 6. Now this is a point on the unit circle, so it would have two coordinates. What's the first coordinate? That is cos pi by 6. This is like x, cos x comma sine x. X is here pi by 6. Cos 30 and sine 30. Now this can be proved that with, I have just stated here that cos 30 degree is root 3 by 2 and sine 30 degree is 1 by 2 here, remember. So I have written here directly sine pi by 6 is 1 by 2, cos pi by 6 root 3 by 2 over here. And one more standard value which is here 30, then 45, then here you have 60 degree. This one. Let me call this as point R for example here. So this is pi by 3. Pi by 3 means 60 degree. So if I write here, let me write here P of, let me write here pi by 3. Now this is again a point on the unit circle. So it would have two coordinates. The first coordinate is cos pi by 3, sorry. Second coordinate is sine pi by 3. Right? Now cos pi by 3 and sine pi by 3, this can be proved that actually this coordinate is nothing but, we can show that cos pi by 3 is nothing but 1 by 2 and sine pi by 3 is nothing but the root 3 by 2. It is just the reverse of this. It is just the reverse of this. So we can say that cos pi by 3 is 1 by 2, sine pi by 3 is root 3 by 2. This one cos pi by 6 root 3 by 2, sine pi by 6 1 by 2. It has proofs, remember, it's like theorems. We are stating without proof. Right? And these values we have stated. So these are the standard values, 0, then this is 30 degree, then this is 45 degree, then this is 60 degree, this is 90 degree, this is 180 degree, this is 3 pi by 2. So here you can write 180 plus 90, so 270, then here it becomes one complete rotation, which is nothing but the 360. Right? So that way we have standard values here, remember. So this is very important table in that sense, and all standard values on the unit circle, which you should know. That's why I have stated here. Now next concept is about even odd functions. So here I'll write a function in general. A function f is called even, function is called even if you find f of minus x, you find f of x, both must be equal for every x. Even function means what? In the formula of the function, if you put x or minus x, both the values should be same, like this, and it has to be true for every x. You know that this is read as for every x. For example, you take fx equals to x square here. Right? Now you write here 1. What is f of 1? 1 square, which is 1. You write minus 1. What is f of minus 1? Which is minus 1 square, which is 1. So you see both are equal. At 1 and minus 1 values are same. Go to f of 2. What is that? 4. What is f of minus 2? Minus 2 square, which is also 4. So both are equal. What is f of 3? 9. What is f of minus 3? 9. So both are equal. So a function for which its opposite and given variable are equal. 2 and minus 2 are equal. 3 and minus 3 are equal. 1 and minus 1 are equal. So such a function is called even function. So this is an example of even function. Right? If you take for example one more, x raised to 4 for example, fx equals to x raised to 4, this is even function. You put minus and the variable itself, value will be same. You take fx equals to x raised to 6. These all are even functions. Even functions. Now, here you look at to this function, a function f. Function f is called an odd function. An odd function if f of minus x gives us minus fx for every x. So that minus sign will come out here, remember. Minus sign will come out, so minus fx. Here, that minus sign has no effect, so it's an even function. Here minus will come out, so it's an odd function. Like this, you take fx equals to x cube. Find f of, for example, minus 2. It is nothing but the minus 2 the whole cube. So it is minus 8. See, minus has already come out. Now you find f of 2. What is f of 2? That is 2 cube, which is 8. So what's the difference between these two? You see minus sign. They are not equal. If there is a difference of minus sign, I mean in another language, if minus sign is out from this, then such a function is called odd function. It is not necessary that every function is always even or odd. There are the functions which are none of these two. But our interest, if you take even this here, x raised to 5, x raised to 7, all are odd functions. Our interest is mainly for trigonometric functions. So for Trigo functions, I'll write for Trigo functions. For Trigo functions, if I write, without proof I'm writing, later on you will realize as you move further. First one, for cos function, if I write minus of angle, see this is like f here, remember. F of minus x, and this is cosine of x. This is our angle x, which is a variable, arc length. Here variable x and minus x both are equal. For cos function, these are always equal. For every arc length, you can verify. So cos is nothing but which function? Even function. This is an example of even function. And if cos is even, sec being reciprocal of this, it would be again even. So if you, this is just the reciprocal. So sec of minus x is again sec x. So this is also an even function for every x in the domain. So these two functions are nothing but even functions. Even functions. What is the meaning of this? These two functions are even. That is, if you put the minus sign here, then this will not have any effect. What I'm trying to tell you, for example, if you find cos minus 90 degree, it is same as cos 90 degree. So here, if I write like this, for example, if I go to next page, for example, if I find cos of minus 90 degree, it is same as cos 90 degree. And what is cos 90 degree? You know that it is 0. If you find cosine, for example, let me write minus pi by 6. So it is same as pi by 6 means 30 degrees. So it is same as cos pi by 6. You know what is cos pi by 6, which is root 3 by 2. If I write cosine minus pi by 4, being an even function, that inner minus has no effect. So this is cosine pi by 4. What is cos pi by 4? Which is nothing but the 1 by root 2. If I have, for example, sec minus pi by 3, it is same as sec pi by 3 because it's an even function. What is sec pi by 3? It is 2. So this is what we understand by concept of even function. That inner minus has no effect. This minus has no effect. Value will be the same as that is what of plus. That inner minus has no effect. This inner minus has no effect. That's one thing. Now for the other trigonometric functions, if I go to third Trigo function now, that is sine of minus x. Now before I get into next trigonometric function, I'll just state that this is same as minus sine x. That is, here minus sign will come out. Remember, for every x, whenever that x is defined. So what's the meaning of this? Sine is an odd function, and when sine is odd function, obviously cosec would be an odd function because cosec is reciprocal of this. So this would be minus cosec x. Now go to tan function next. Fifth one, tan function, tan of minus x. Right. So here sine is odd, so their minus sign will come out, whereas cosine has no effect on sine, so you can have minus tan x. Just think. So this is also an odd function. And last one, sixth one, cot of minus x, that is just the reciprocal of this, so this is minus cot x. So these four functions defined in a proper domain, these four functions are nothing but odd functions, even and odd functions. Which two trigonometric functions are even functions? Only cos and sec. Cos and sec are even functions, remaining functions are odd functions. So in the other functions, if you have minus sign, it will come out, minus will come out, minus will come out, minus will come out. How do we understand this? For example, if I want to get sine minus 30 degree, this being odd function, take minus outside, so minus sine 30 degree. What is sine 30 degree? You know it is 1 by 2, so minus 1 by 2 is your answer. If I come to, for example, cos 30 degree, minus 30 degree, let me write. Now cos is an even function, so it is as good as cos 30 degree, so it would be root 3 by 2. Now next I'll come to tan, for example, tan 60 degree. Let me write tan pi by 3, for example, which is 60 degree, you know. Now what is tan pi by, let me add minus here. So minus sign will come out. This is tan pi by 3. What is tan pi by 3? You need to remember. So here, this tan pi by 3, you know that it is root 3. So minus root 3 is your answer. Suppose next I want to get cot minus 45 degree. So this is same as minus cot 45 degree. Okay. Now what is cot 45 degree? It is 1. So you have minus 1 because minus sign is there. So for these four functions, you have that minus outside. You see this minus will come out. And therefore, these functions are called odd functions. And the previous two which I have stated, that is which two functions? Cos and sec are called even functions. Okay. So after knowing this, now we want to discuss graph of trigonometric functions. So next point is about graph of trigonometric functions. We try to draw the graph of first sine, then cosine, and then tan. Graph of trigonometric functions. Trigonometric functions. We already discussed graphs of some standard linear function. For example, you know that it is a straight line. Then graph of, you know, quadratic function, parabola, you know that it is nothing but that cup shape, if you recall. Then step function and so on. Now we discuss the graph of trigonometric function. These graphs are very important and interesting also, you will realize. So I'll try to draw the graph of first sine function here. So let's start with sine function. So for the graphs of trigonometric functions, here first we start with fx equals to, for example, sine x. Now what we do, if you remember, we used to prepare such table x and fx. Here we can call this as y also. We take values of x of our choice. Usually in linear and quadratic we used to take 0, 1, 2, 3, 4. But here we cannot take 0, 1, 2, 3 because we don't know what is sine 1. So we take values from the unit circle, remember. We take the values from where? The unit circle. We start with this. We take 0, then pi by 2, then pi, then 3 pi by 2. Then the other four values we take in this direction. That is 0, minus pi by 2, minus pi, minus 3 pi by 2 and so on. So I'll try to take the values in this way. Okay, so I'll take 0 first, then I'll take pi by 2. You cannot take 1, remember. Then I'll take pi here, then I'll take 3 pi by 2, then I'll take 2 pi. Right? And if you want, you can take negative values. Now we put here, what is sine 0? 0. What is sine pi by 2? Sine 90 degree 1. If I put pi here, what is sine pi? 0. If I put here 3 pi by 2, sine 3 pi by 2, just have a look at unit circle. This is minus 1. You know that 3 pi by 2 is here. So coordinates are 0, minus 1. Sine function represent which coordinate? Second coordinate, so minus 1. 2 pi here, so 0. Now you can take further more values if you want. Now what we do, how do we draw the graph? We represent this 0, 0, pi by 2, 0, pi, 0, 3 pi by 2, minus 1, 2 pi, 0 in this Cartesian plane. Okay, so here I have 0, this is origin. I'll show here pi by 2 on the x-axis, pi, then 3 pi by 2, then 2 pi. Here I'll show minus pi by 2, that means you are moving in clockwise now. Minus pi, minus 3 pi by 2, and this is minus 2 pi. You know that the maximum value of the sine function is 1. So here it is 1. It will never go beyond 1. Minimum value is minus 1. So graph will be in this strip only. Maximum value is 1 here. You know. Minimum value is minus 1 here. That we know. Okay, now we represent this ordered pair. 0, 0. That is this origin. Right? We plot these points in the Cartesian plane. Pi by 2, then 1. Pi by 2, then 1 here. Pi, then 0. So it is here. 3 pi by 2, then minus 1. So it is here. And finally 2 pi, then 0 over here. So it would be like this. It will go off first, freehand curve, remember. Then it will come down. Again it will come down. And then again from here it will go up. Like this. Okay, if you remember, see here 0 to pi by 2, which quadrant? First quadrant. You see graph goes up, value increases. So in the first quadrant, sine is an increasing function. This is not like this. Don't draw like this, remember. It's not like this. It's a curve shape like this. Okay, 0 2 pi by 2, first quadrant, graph goes up, so it's an increasing function. Pi by 2 to pi, which quadrant? Second quadrant, graph comes down, it's a decreasing function. Pi by 2 to pi, which quadrant? Third quadrant, graph comes down, it's a decreasing function. 3 pi by 2 to 2 pi, which quadrant? Fourth quadrant, graph goes up, so it's an increasing function. So in the first and the fourth quadrant, sine is an increasing function. Now what happens if I continue further? You know, now values being repeated. So now you are taking second round around the unit circle. So if I start from here, the next point is 2 pi plus pi by 2, which is 5 pi by 2. 5 pi by 2 is as good as pi by 2 during the second round. During the first round it was pi by 2, but when I go to second round it becomes 5 pi by 2. So this point. So at 5 pi by 2 it is 1. So graph goes up. Whatever happened at the first 0 to pi by 2, same thing is happening in 0 to 5 pi by 2. Right? Then I'll come down here, which is 3 pi during the second round. So here you have 3 pi. Now what about this? 3 pi is same as pi, so value becomes 0 here. So again graph comes down, that is this portion. You are just copying this and you are putting here. Next you come here, that is nothing but what now? 7 pi by 2. Earlier it was 3 pi by 2. Now at 3 pi by 2 it is minus 1. So at 7 pi by 2 again it is minus 1. So now this is, if I show 7 pi by 2, then this is minus 1. Here minus 1. Minus 1, remember. And if I complete the second rotation here, if I complete the second rotation, this becomes 4 pi now. This is 4 pi where the value is 0. 4 pi is here, that was 0. Yes, 4 pi after second rotation. So initially 0, then 2 pi and then 4 pi. So now this is 4 pi and so on. So up to this, you see, this is called one cycle. up to 2 pi. This is called one cycle of sine function. And then 2 pi to 4 pi, it's a second cycle. This is a second cycle. You just cut this graph and you paste over here. You just cut from here and paste here. So values being repeated. आप देखो इसका copy है यहाँ पे और कुछ नहीं है. So this is when values being repeated after certain interval, then it is called periodic function. So we say that sine is a periodic function with the period 2 pi. We say that sine is a periodic function. Periodic function means what? Values being repeated after certain point. Periodic function with period equals to 2 pi. This is sometimes called the principal period also, remember. Some authors use this word also, principal period, main period. Principal period, remember. What's the principal period of sine function? Principal means main, which is 2 pi. Why 2 pi is the principal period of the sine function? Because after every interval of the 2 pi, the values being repeated. You take this portion, that is same as this portion. You see behavior of the graph is same from 0 to 2 pi and from 2 pi to 4 pi. So this is called periodic function with the period 2 pi. Now, you must have realized, see, if I draw the graph in this portion also, minus 2 pi 0, it would be the same only because this is also period 2 pi. See, I am drawing the graph at minus pi by 2. Where is minus pi by 2? Here. Value of the sine function is minus 1. So here. Now I am not using this table because you know unit circle very well. So here at minus pi by 2 here, value minus 1. So graph comes down. Minus pi is here. There the first coordinate is 1, second coordinate is 0. So sine function becomes 0. So it is here. At minus 3 pi by 2 here. So at 3 pi by 2, minus 3 pi by 2, it is same as pi by 2, which is 1. So here it becomes 1. Okay, so here it is 1, remember. Minus 2 pi same as 0 here, you know, minus 2 pi same as 0. So again it will come down and so on. So this is again, you see, it's the same graph, one more cycle. From here, you just cut the graph in this portion, it is same as this, paste over here. You cut from this, paste over here, and so on, you can continue, right? In every interval of the 2 pi length, values of the sine function being repeated, and that's why this is called the periodic function with the period 2 pi. Not only that, you must have noticed, you see the graph passes through the origin, and at 0 it is 0. So here 0. At pi it is also 0. At 2 pi it is also 0. At 3 pi it is also 0. At 4 pi it is also 0. At minus pi it is also 0. So these are called the zeros we have noted. What are the zeros of the sine functions? Zeros equals to n pi, you know. What are the zeros of sine function? You know, these are nothing but the n pi, where n belongs to z. Again, emphasizing sine is a periodic function with the period 2 pi. After every interval of the length 2 pi, values being repeated. So this is one cycle, this is another cycle, this is another cycle, and so on, right? And set of zeros is n pi. In the first and the fourth quadrant, graph goes up, so it's an increasing function. In the middle two quadrant, it's a decreasing function. That we already noted earlier. Now we go to graph of cosine function. Okay, so for cosine function, fx equals to cos x, I'll take different values from the unit circle, as you know. 0, pi by 2, pi, 3 pi by 2, 2 pi, and so on. 0, cos 0, 1, pi by 2, cos pi by 2, 0. Then come to pi, cos pi here, minus 1, comma 0. First coordinate is minus 1, so here minus 1. Then next you come to 3 pi by 2. 3 pi by 2 is here. There you have 0, comma minus 1. So this is 0. Then you come to 2 pi. 2 pi is here. Then the first coordinate is 1. 2 pi is here. 2 pi is here. Then the first coordinate is 1. So this is nothing but 1. Right? This way we have values of the cosine functions in one rotation. So I'll show this in this Cartesian plane. 0, I'll write here pi by 2, then next I'll write here pi, then 3 pi by 2, and then 2 pi. Here I'll show one cycle on both the sides. So this is minus pi by 2, this is here minus pi, this is minus 3 pi by 2, and minus 2 pi. One cycle you will see. Okay, maximum 1, minimum minus 1, you know. Now what about cos? Here at 0 it is 1, so graph starts from here, remember. At 0 it is 1, so graph starting from here. So graph of the cos function does not pass through the origin. Look at it, previous graph, it was passes through origin. Pi by 2 it is 0, so now graph will come down here. At pi it is minus 1, so here graph will again come down. At 3 pi by 2 it is 0, so it would be here at 3 pi by 2. And at 2 pi it is 1, so you have here. So this is one cycle of cos functions. This is one cycle of cosine function. From where to where? 0 to 2 pi. You see at 0 it was 1, so it was starting from here. At pi by 2 it is 0. At pi it is minus 1. At 3 pi by 2 it is 0. At 2 pi it is 1. So from 0 to 2 pi we have the graph like this. You see here in the first quadrant 0 to pi by 2, this is pi by 2, you know. Here graph comes down, so it's a decreasing function. Pi by 2 to pi, second quadrant, graph comes down, decreasing function. Recall that table about increasing and decreasing, you can compare this. Pi to 3 pi by 2, third quadrant, graph goes up, it's an increasing function. 3 pi by 2 to 2 pi, graph goes up, so it's an increasing function. So in first quadrant decreasing, decreasing, increasing, increasing. This is one cycle of cosine function. If you want to draw here 2 pi to 4 pi, you just cut this and paste there, so that way it continues. Here it is again the copy paste of this. Minus pi by 2 on the unit circle, it is here 0, first coordinate cosine function, so graph will come down. Then come to this minus pi, it is minus 1, so graph is here 0, then like this here. At 3 pi by 2, minus 3 pi by 2 is here on the unit circle. There the value is 0, you know. Your first coordinate is 0, 0, 1. Here 0, minus 1. So graph goes up. At minus 2 pi, it is here. There the value is 1. So graph will be here, like this. So you can see that it is like this in curve shape. Here, this portion here, this portion is just, you cut here, you can paste over here. Maximum value is 1, remember. So graph never go beyond this. Graph never go beyond this. These are the maximum and minimum values of cos functions, remember. And it continues, it will come down here, again it will come down. So it's like this. It's like this, remember. This way it would continue. If I show like this, it would continue like this. Right, with this 0, pi by 2 and so on, that way. You can just refer the textbook. Okay, and here again there's a periodic function, as I mentioned. It's a periodic function with period equals to 2 pi again, period equals to 2 pi. Okay, so this way we have the graph of, you must have some basic idea about the graph of such functions, remember. That's why I'm emphasizing on this. Okay, now we go to the next function, which is about cot function. Next I want to draw the graph of tan function first. Okay, next tan function, so fx equals to tan x, you can call the y also. Now if you remember here, the range of the function equals to all real numbers. range of sine and cosine were close interval -1 to 1. So we had a graph between -1 and 1. Here graph is in the entire plane, remember, because range is R. Okay, what will be the period? You will realize. So I take some values here. For example, if I take 0, tan 0 is 0. Why? If I take 45 degree, you know tan 45 degree is 1, for example. Then at pi by 2, it is not in the domain, undefined. I'll put dash, right, for such values. So here 0. If I write pi by 2 here, there the tan is undefined. Undefined means infinity. So I'll just put the dotted line here. This dotted line indicates that here tan is not defined. It becomes very large. 0, pi by 2. Then here you have pi. Then here you have 3 pi by 2, for example. Again at 3 pi by 2 it is undefined. Look at the domain of the tan function, you will realize. R minus 2n plus 1 pi by 2. So you are not going to take multiple of pi by 2. If I write here minus pi by 2, again tan is not defined. Not defined means infinity. So I'll show dotted line here. Here you have minus pi. Then over here minus 3 pi by 2. So here also I'll show dotted line. So this is a dotted line. Minus 3 pi by 2. This all dotted line indicates that here tan is not defined. Fine. And graph would be in the entire plane because the range of the tan function is R. Now if I start with this 0 then 0. So graph passes through the origin. You know pi by 4 or 45 degree here. Exactly in the middle of this, that is 1, if this is 1. Now as you take values very closer and closer to this, it would be very close to this. At pi by 2 it becomes infinity, so very close to this, like this. This is pi by 4, remember, 45 degree. At 45 degree it is 1, at 0. At pi by 2 it becomes infinity. Infinity means very large on the y-axis. I'll show here, close to this. It will not cross this, it will not touch this. Minus pi by 4 here, at minus pi by 4, you know tan is an odd function, so it becomes minus 1. If I take minus 45 degree, it will be minus 1. Now you know tan is an odd function. This one you know, tan minus 45 degree. That is same as minus tan 45 degree, and tan 45 degree is 1, so this become minus 1. This is an odd function, now you know that. So here it is minus 1 somewhere here. This is minus 1, remember. At minus pi by 2 it is very large but negative y, remember. So it will pass through this and it would be like this. So this is the graph of tan function. You see 0 to pi by 2, it's an increasing function. So graph always go up. If you move from left to right, graph always go up. So if you remember the table, we had stated that tan is increasing function in each quadrant. It's not like increasing, decreasing here, remember. It goes up, so it's an increasing function. Okay, now come to this portion. Pi, here if I write pi here, tan pi, you can just recall sine pi upon cos pi, so it is 0. So here, at pi it is 0. At 3 pi by 2, it's same as pi by 2, so it will be very close to this. So like this here. Then here you can take one values pi by 2, but now here it would be negative, so it would be this. So what you have realized? This is just the replica of this. Minus pi by 2 to pi by 2. You cut this and you paste here. This is a little bit broader because I took the values in this way. But this portion is just the copy of this. And now what is the length of this minus pi by 2 to pi by 2? It's a pi. So you can say that tan is a periodic function with the period equals to pi, remember. What's the meaning of this period pi? After every interval of the pi, values of the tan function being repeated. Right? You see this portion is same as this. This length is also pi by 2 to 3 pi by 2. This is pi by 2, you know. Now what about this portion, minus 3 pi by 2 to pi by 2? Same, you just cut from here and paste here. This is 0. Here it is minus infinity. So it would be like this. Here if you go up, it would be increasing like this. This is the graph of time function. How many cycles I've shown here? 3 cycles. 1, 2 and 3. This is the graph of time function. Now you just refer the textbook and try to draw the graph of cot function, cosec function and sec function. You will see that if you draw the graph of cot function, it is a decreasing function. Cosec, sec are not so important, but at least cot you must try. It would look like this only. The other 3 graphs you just refer the textbook and try to draw. So this remaining 3 graphs, which graphs? Cot function, cosec function and sec function. Try. This is for you as a homework, right? You must be capable to drawing the graph of the other 3 functions now. You can refer the textbook. These graphs are already there in the textbook.